the way to get rid of a radical is to square both sides. If I take this side of this equation and square it, and I take this side of the equation and square it, the square root squared, these are inverse operations. It's just like when we're trying to solve, if we've got 5x equals something, we divide by 5. You do the opposite of what's already there. So if the square root is already there, the opposite of that is to square it. The square root of x squared is always going to be just plain x. And then the square root of 25 is, square root of 5 is 25. If I had the square root of 2x plus 3 equals 5, then I could square both sides of this. And even though there's more than one thing in the radical, the square root of that squared is still just itself. So it's this side that doesn't have the radical that I have to actually square. Now you have to ask yourself if this is linear or quadratic. It could be both. Well, it can't be both, but it could be either. This is linear because there's no x squared. Therefore, it's linear. So what I want to do is move the 3 over here with the 25. Divide by 2. X equals 11. Now, there is a problem with squaring both sides of an equation. If I have a number in my mind and I square it, and when I square it, I get 4. So I've got some number, and when I square that number, I get 4. That number, most people are going to jump up and say, well, it was a 2, right? But couldn't it have been a negative 2? 2 squared is 4. But negative 2 squared is also 4. And whichever one you guess, I can just say I was thinking of the other one because it's in my head and you can't tell the difference. Well, the same thing here happens kind of when you square this. The 4 doesn't have a little tag on it that says, oh, well, this 4 came from squaring a negative 2. No, it's just a plain old 4. So you can actually pick up answers after you square both sides of a problem. By squaring both sides, you can pick up answers that do not work in the original problem. So we have to check all the answers. You must check the answers when you square both sides of a problem. And of course, you can't just square one side. So I have to check this real quick. So this would be the square root of 2 times 11 plus 3. That's supposed to equal 5. This would be the square root of 22 plus 3, which is square root of 25, which is 5. So it works. You have to isolate the radical before you square both sides. If there's anything on the same side of the equation with the radical, you have to move it to the other side. So you isolate the radical, and then you raise both sides of the equation to the index. That's the little number in the corner of the radical that tells you what kind of radical it is, whether it's a square root or a cube root or a fourth root. Solve the resulting equation. Make sure you ask yourself if it's linear or quadratic, because you treat those differently. If it's linear, you want to get the x terms on one side, the constants on the other, divide by whatever x is multiplied by. If it's quadratic, you want to set everything over to one side, set it equal to 0, and then factor it. And then you must check all answers. It's not an option, because you can pick up answers that don't work. Now I'm going to show you how to check and find out whether they're what they call extraneous roots. Extraneous roots are the answers that would have worked if the sign in front of the radical was different. For example, what if we had the square root of x plus 3 equals 7? If the square root of, if something plus 3 is 7, what plus 3 is equal to 7? What do you have to add to 3 to get a 7? This has to be a 4, right? If you were to square each thing here and say x plus 9 equals 49, if you squared that and you squared that and you squared that, it doesn't work, because this way x would have to be 40, and the square root of 40 plus 3 is never going to equal 49. Or it's never going to equal 7. The only thing you can add to 3 and get 7 is if this is a 4. This doesn't work. This is why you have to isolate the radical first. If we start with the square root of x plus 3 equals 7, we absolutely have to subtract the 3 from both sides first. This will quarantine the x. Get the square root of x by itself. Now, I can square both sides. That'll cancel that out, and I end up with x equals 16. And if I check, then I've got the square root of 16 plus 3 is supposed to equal 7. Gives me 4 plus 3, which is 7, which equals 7. Check. I would kind of like to leave that there, but I think in order to erase this stuff, I have to erase each and every little thing one at a time, so it would take forever. So let's go to the next page and I'll look at another problem. What if we had the square root of 2x plus 5 equals 0? Isolate the radical. So the first thing we have to do is subtract 5 from both sides. Square root of 2x equals -5. Now I'm going to square both sides. The square of the square root just leaves the 2x equals 25. Divide by 2. X equals 25 halves. Now, check. This would be the square root of 2 times 25 halves plus 5 equals 0. These 2's cancel. This stuff is actually going to be really easy to check. That's the square root of 25 plus 5, which is 5 plus 5, which is 10. Oops. Well, that didn't work. Now, how do you figure out whether I did something wrong or whether this is what they call an extraneous root? Well, an extraneous root is the one that would have worked if the sign in front of the radical had been different. If it had been the negative square root, then this would have been a negative square root of 25. This would have been a -5, and this would have turned out to be 0, and it would have worked. So 25 halves is an extraneous root. An extra answer that doesn't actually work. I got to show you one more. If you have something like the square root of x plus 7 plus 5 equals x. First thing we got to do is subtract 5. So the square root of x plus 7 equals, so I can't add those together. When I square both sides, this is not going to just square that and square that for the same reason that I can't do individual squares. This part turns out to be the easy part. Square root squared is just itself. This has to be FOILed out. And because we're a little short for time, I'm going to FOIL that out, and it's going to be x squared minus 10x plus 25. I already know what it's going to be. Now, this is quadratic. Because it's got an x squared in it. So I don't want to try to separate the terms. It won't do any good. I've got 3 kinds of terms. I've only got 2 sides to put them on. I need to set this equal to 0. So I'm going to move them over here because my x squared is positive, and I like it that way. Leaves me 0 over here. X squared minus 11x plus 18. I want to find factors of 18 that add up to 11. 18 could be 1 times 18, 2 times 9, 3 times 6, 4 won't go, 5 won't go. I already used the 6. Okay, this adds up to 19. That adds up to 11. That adds up to 9. So the 2 and the 9 is what I want to use. To get a negative 11 out of those, it's got to be a negative 2 and a negative 9. So x, minus 2 equals 0, or x minus 9 equals 0. So x is 2 or x is 9. Now, I have to check both answers. A lot of times, one of them will work and one won't. Sometimes they both work. I've even seen problems where neither one will work. So checking one doesn't give me even a clue as to whether or not the other one is going to work. So if I check the x equals 2, then I get the square root of 2 plus 7 plus 5 might or might not equal 2. As square root of 9 plus 5, which is 3 plus 5, which does not equal 2. Is that an extraneous root? Well, if this had been a minus, that would have been a minus, that would have been a minus, that would have equaled 2. So that's an extraneous root. I always like to check because otherwise you can't tell whether it didn't work because it was an extraneous root or because you made a mistake. Okay, try x equals 9. That would be square root of 9 plus 7 plus 5 might or might not equal 9. Square root of 16 plus 5 is 4 plus 5 is 9 equals 9. Boom. So the only answer here that works is the 9. If you put both answers in, if you just automatically put x equals 2 comma 9, my math lab's going to say it's wrong. And so here you're going to be up here looking, trying to figure out where you made a mistake. And this is a pretty long and involved problem. And there's not a mistake in it. If on squaring these problems, if you think you worked it right, and my math lab says it's wrong, the first thing you need to do is check your answers if you forgot to do so. If it says you're wrong, you probably didn't check those answers, right? So check your answers See if you have an extraneous root. You can tell the difference by changing the sign in front of the radical and seeing if that would have made it work. If it's an extraneous root, erase it. If they're all extraneous roots, or there was only one and it doesn't work, then put no solution. It's really disgusting to do this much work on a problem and then have to put no solution. It's like, that's an awful lot of work to do for nothing. But sometimes it works that way and there's nothing we can do about it.